Good morning friends, myself Manish Kumar, an architect presently working as a lecturer at Government Polytechnic College for Girls, Patiala. My today's topic is isometrics. It is for second semester students of architecture assistantship, and in this lecture we will cover isometric projections of non-isometric edges. In my previous lectures we did basics of isometrics and some simple examples. So let's start with the projections of isometrics. First of all, we will take example. Say in exam there is a question like this: draw isometric projections of a square pyramid of base side say 5 centimeter and height of axis as say 10 centimeter, right. This is a very simple question. Draw isometric projections of a square pyramid, right, of base side 5 centimeter and height of the axis as 10 centimeter. First of all of you must know what is pyramid. If you don't know what is pyramid, then it will be very difficult for you. I hope all of you know what is pyramid. Like, I will draw first orthographic projection of pyramid, just in rough part. This is plan, right, and this is elevation, right. This is plan, this is elevation, and this height here is 10 centimeter and side of the pyramid is say 5 centimeter, right. For drawing its isometrics, we will start with our basic steps. For drawing any isometrics, we start with a straight line, horizontal line, right. This line is say ground line, GL, ground line, right. On this we draw an inclined line at 30 degree like this. This is at 30 degrees and this line will represent lengths of the objects, and we will draw a second line perpendicular on ground line. On this line we can take height parts, right, and third line we will draw like this, which is again at 30 degree. On this line we will take say breadth parts, breadth components, right. Okay, so first of all what we will do, say this is point A, this is B, this is C, this is D. This whole part is rough, right. Say this point is here A, right. So for start to what we will do, we will mark 5 centimeter on this length line from point A. Say this distance is 5 centimeter and breadth also is 5 centimeter as it is a square pyramid. We will mark breadth here. Right. Then we will get point C. How we will get point C? We will draw a parallel line from this point. Say this, if this is A, this point will be B, this point here will be D, right. as we know, AB is parallel to DC. So, we can draw a line parallel to line AB like this, right? And BC is parallel to AD. We will draw a line like this. Both of these lines are at 30-degree angles, right? Intersection of this will give us point C, right? In this way, we have all the base points of our square pyramid A, B, C and D, right? And next, we need to mark height, right? What students often do is, they just mark height on this vertical line, height line, right? They mark it as 10 centimeter here and join all these lines like this. This is not right, right? This is wrong. What they should do is, right? Say this is A, B, C and D. This is a height line, right? First of all, they should work out the base of the axis. Base of the axis will be here, like we can get base, join B and D, join A and C. This will give us a point here. Actually, this is the base of the axis. We can draw a vertical line here, right? Right? On this vertical line, we can take 10 centimeter from here. Say this is O dash, right? From here, we will mark 10 centimeter. Say 10 centimeters are here, right? First, we will work out the base of the axis. Base of the axis will lies in the center of the square pyramid's base. So, here we have marked 10 centimeter. This is 10 centimeter from here to here. Now, join all the points like we can join point C also. That point will be hidden basically. So, this will give us isometric projections of a square pyramid, right? In the end, we can dark all these lines which are directly visible like this line also, this from A, right, and this AB and AD line, right. This will give us isometric drawing of a square pyramid with 5 centimeter side and 10 centimeter height of the axis. Another way of doing this is like this. First of all, we will calculate maximum length, maximum breadth and maximum height. If it is a square pyramid like this, its maximum length is 5, maximum breadth is 5 and maximum height is 10, right. What we will do is, we will draw a cuboid with these dimensions, like we will take 5 here, we will take 5 here, right, and we will take 10 on height line, right, and we will complete a cuboid. Right. This is a cuboid with length 5 centimeter, breadth 5 centimeter and height as 10 centimeter. Now, this will give us a box which encloses our square pyramid, right. So, to find apex, join top of the box diagonals. This will give us apex point O, right. Now, join these apex points with all the points, all the base point like this, right. This is another way of solving the same problem. What we have done here is we have enclosed our object into a box which is a cuboid of 5 into 5 into 10. Then we have simply worked out our pyramid, right? And write here projections of isometric projections of given pyramid in capitals. We will take another example. Say in another example there is a question, draw, statement type question again, draw isometrics of say regular pentagonal say prism, and side of the pentagonal prism is say again 5 centimeter and height is say 10 centimeter. So, for drawing isometrics of this regular pentagonal prism, first of all we will draw its orthographic. Say regular pentagon is like this. We will draw it exactly on scale. So, this is our regular pentagon with each side having dimension of 5 centimeter, right? Draw its elevation also. This point will be dotted. I assume all of you know how to draw orthographic of this regular pentagon. Say this is point A, this is point B, this is point C, this is point D, and this is point E, right? And all these points have oblique points B dash, C dash, D dash, A dash, and E dash. For drawing this, first of all we will draw orthographic projection, which is like this. In this, what we will do, we will enclose this again in a box. How we will do this? We will draw a line like this. We will draw a second horizontal line like this, right? And a vertical line like this, and a vertical line like this. Right? Say this is point 1, this is point 2, this is point 3, and this is point 4, right? Right? What we will do, first of all we will draw a box 1, 2, 3, 4 and 10 centimeter height like this. I will quickly draw all this, right? These are basic steps. Say this is point 1 and we will measure this from 1 to 2, right? We will actually measure, say point 2 is here, right? And we will measure 1 and 4, this distance. Please note we have to actually measure it, right? Say this is 4. And we will mark height, which is as per our question 10 centimeter. Say this is 10, right? And complete the cuboid. Okay. This is drawing of a cuboid which contains our regular pentagonal prism, right? We have point 1 and 2, 1 and 2 here, 1 and 2. On 1 and 2 we have point A and point B, right? Measure from this orthographic drawing, this distance from point 1 to A, say this is like this. Measure this distance with compass. You can mark like this. This will give us point A dash base point, right? Then measure this AB with compass, which is 5 centimeter. Mark like this. This is point B, right? On this edge E, measure this distance from point 1 and mark it here. This will give us point E. We have point A, we have point B, right? For marking point C and D, we will complete base in guidelines only. Base of the box like this. Say this is point 3. On 2 and 3 edge we have point C. We will simply measure with compass and mark point C here. So this is point C, right? And point D is on edge 4, 3, which is this edge 4, 3 here. On this we will measure, mark point D. Now we have all the points of our pentagon. We can join them freely with scale like this. We will join A with B, right? Then B with C in guidelines only. Initially we will join all these points with guidelines only, right? Point A with B, point B with C, C with D, and point D with E, and point E with point A. This way we get plan of our given pentagon, right? As there are principles which says perpendicular lines remains perpendicular lines in isometrics. This is a principle of isometrics. So what we will do, we will simply project vertical lines upward from all these points A, B, C, D and E like this. These are vertical line from C also, from D also, and from E also onto the corresponding edges, right? So what we get is, we get point A, from B we get point B, from C we get point C on these edges, right? And for point D, we will mark this on this edge, right? This way we get all the 5 points of a regular pentagon. Now what we have to do is, we have to simply join like this. Join A with B, B with C, C with D, D with E, and E with A. Now we can dark. From top, all the 5 points will be visible. We will dark all these 5 points, and this vertical line will also be visible directly. We will dark this also, right? This edge will also be darker. All visible edges will be dark, right? You will mark just one bold line, right? And this vertical edge will also be visible. We will dark this, right? So this gives us a isometric drawing of a regular pentagon with given dimensions. What we have done here is, we have simply enclosed our pentagon in a cuboid, right? And measured these cuboid and draw its isometrics, and then from cuboid work out the points A, B, C, D just simply by measuring from this drawing, this plan. So this plan must be to the scale, right, and drawn accurately. And for taking points, we can use compass or scale. We can measure this point with scale or with compass. I hope it is clear to you, students. Now we will take another example, a little complex. In the exam, there can be questions like this: draw isometrics from given orthographic projections, right. Given ortho projection can be drawn onto your question paper. Say we have a plan and elevation given orthographic projection like this. Can be anything, say it is something like this. This line is straight, say this is straight. And in elevation, say our object is something like this. This is not very accurately drawn. Say this dimension here is total 6 and this point is 3 and 3. All dimensions are in centimeters, say. And this dimension here is, say, total is 5, right here like this, right, and this dimension here is say 2 centimeters, right, and this dimension here is say 1 centimeter, right, and elevation is something like this, and an elevation, say this total height is say 4 centimeter, and this height is say 1 centimeter, and this height is say 3 centimeter, right, and this height is say say 1 centimeter, right. So we have a complex example in which orthographic projections are given to us in the forms of plan and front elevation, and we have to draw isometrics from this given drawing. So what we will do, we will start exactly the same way. We will draw a line, horizontal line, which represents say ground line, right. On this line we will draw 3 axes, one towards right at 30-degree angles, one towards left again at 30-degree angles, and one vertical, right. Say these are 3 axes, one for length components, one for breadth components, one for height components. In this example also we have so many non-isometric edges, like this edge is non-isometric, this edge is non-isometric. So how to draw the drawing? The right way to draw this is, we will work out maximum length, maximum breadth and maximum height. That means we will enclose our drawing or object into a cuboid. So maximum length is say 6 centimeter from here, right, and maximum breadth is, from plan we can make it is 5 centimeter, and maximum height from elevation we can clearly see it is 4 centimeter, right. So what we will do is, first of all we will make a cuboid with these dimensions, these maximum dimensions, right. Say this is 6 from here to here, right, 6 centimeter. Initially we draw everything in guidelines only, right, and say breadth is 5 centimeter, mark breadth on left, right, say this is 5 centimeter here, height height is 4 centimeter, mark 4 centimeter on height line and complete the cuboid in guidelines only. So what we have done here is, we have drawn a transparent box and our object will fit exactly in this box, right. So first of all we will divide our object into some simpler cuboid. Say first we do this part, means base, right. Base is from plan we can make that base is like this. It's not a rectangle, complete rectangle. It has a chamfered corner, like. So first of all we will draw a base without a chamfer. Without chamfer we can easily draw. From elevation we know that height of the base is say 1 centimeter and its length is 6 and breadth is 5, right. We will mark height on this and draw a parallel line like this and a parallel line like this and parallel line like this and parallel line like this. All these lines are at 30-degree, right, towards left or towards right. So what we have done is, we have completed our base, right, and this base is like this, right. Say this is our starting point, say O. So this is O. Say we have imagined it as a rectangle, right, and this is point O. Say this is point 1, this is point 2 and this is point 3, right. From O we have 1, we have 2 here and we have point 3 here, right. So how to draw this chamfer? We can simply draw, just measure this from O to O to this point with compass, right. This is given 3. So what we will do is, we will mark a point at 3 here, right, and this is also given, total is 5 and this point is 2, that means this is also 3, and mark a point 3 here also. So this distance is also 3, right. Uh, as per rules of the isometrics, vertical lines remains vertical. We can draw vertical lines like this. Now we get point this and this. Now we have to simply join this like this freely with scale, right? So we get a chamfered edge box, right? Now for this part, what we will do, we will make this as one cuboid like this. We will work in this cuboid, say, right? Say this distance is, total is 6, right? Say this is 1, this is again say 1 and this is again say 1, right? So this total is 1 plus 1 2 plus 1 3 centimeter. We will go like this 3 centimeter, and this dimension is 1 in this way. We will take 1 this, right, and vertical lines remains vertical. We will complete our cuboid like this.